Hi there, folks. Today we're looking at graphing using intercepts. And really, this is going to continue us using points to graph lines. But now we're going to start to incorporate that pattern that we've been seeing a little bit more. All right. So, for example, if I look at this first one, it's y equals 2x minus 3. This is one where we would do our xy chart. Notice I used my typical values of -2, -1, 0, 1, and 2. I plugged them in and I got those other values, the range values. And then I plotted those points and it gave me a line. But the thing we've been talking about recently is as we did these XY charts is how many points do I really need? Like if it's going to be a line, if I know it's going to be a line, how many points do I really need in order to graph this thing? Like when can I just take over with the pattern? And hopefully you've been looking at this going, wait a minute. After I have only 2 points, I know what the pattern is and then I could graph it from there. For example, on this line, if I only have these 2 points, well, if it's a line, I already know the pattern was up 2 units and over 1 unit. And from there, I could go up 2 over 1 and get the next point, up 2 over 1, up 2 over 1, up 2 over 1. So as soon as I have just 2 points, I know what the pattern is. And so then I can use that pattern, I can extend that pattern to graph, okay? And so really, the answer here, I only need 2 points in order to do this thing, okay? So once I have 2 points, I could use the pattern, all right? 2 points shows me what the pattern is to get from one point to the next, and then I can extend that pattern, okay? And for this particular example, we already said it, but when I described the pattern from one point to the next, it was up 2, and then to the right 1 or over 1, okay? And so the idea is 2 points gives me the pattern. I can use the pattern to plot other points. So instead of doing an entire XY chart, we're going to use 2 specific points from the graph. And the 2 points we're going to use are the x and the y-intercept. And the reason we're going to use the x and the y-intercept is because they're really easy to find, especially if the equation is in a certain format. And we'll see that in a moment. So the x-intercept is where the line crosses the x-axis, okay? If you think about intercepting something, it's kind of where you cross that thing's path, all right? So the x-intercept is where the line crosses the path of the x-axis, and it exists when y equals 0, all right? So when we look at this definition, it's given us 2 things. Where the line crosses the x-axis, that's visually what we see for the x-intercept, but it exists when y equals 0. Algebraically, that's how we find it, all right? So when we're looking at an equation, we find it by plugging a 0 in for y and then solving for x, okay? So we see it when it crosses the x-axis. We find it by plugging a 0 in for y. Same thing, y-intercept is where the line crosses the y-axis. And again, that's visually what we see. We see it on the graph crossing the y-axis. At that point, that's visually how we identify the y-intercept. It's where it crosses the y-axis. But we find it, when we have an equation, we find it by plugging a 0 in for x. And again, when we plug a 0 in for x, we'll solve for y, okay? For example, if I look at this first one, this is kind of the visual representation. If I look at this thing visually, I just have to say the x-intercept is where it crosses the x-axis. Remember, the x-axis is the horizontal axis. It's this guy right here. So that's the x-intercept. We're just going to write that down as an ordered pair. So think about that ordered pair. It's over 2, and it's not up and down at all, so that's 0. And notice we can also see that plug it in type of thing. Notice the y value equals 0 right now. The x-intercept is when y equals 0, but visually it's the point to 0. The y-intercept, here's the y-axis is the up and down axis, and it crosses the the y-axis right there at that point I just highlighted. And again, that's the ordered pair 0, 4. And once again, we can see that algebraic definition. We have a 0 plugged in for x. When x equals 0, y equals 4. That's the y-intercept, okay? And really, with just those 2 points, we can see the pattern for this line. If I start, and I always count left to right, so I go down 4 over 2. Down 4 over 2. I could plot more points on this thing just after having those 2, all right? For example, if I look at this guy, I want to find the x-intercept and the y-intercept. This time I have to do it algebraically. I have to plug in. So the x-intercept is when y equals 0. So what I'm going to do is I'm going to plug a 0 in for y. So I do 3x minus 4 times 0 equals 12. And now I'm just going to solve for x. Ready? 3x, 4 times 0 is a 0. That's just 3x equals 12. And now I divide each side by 3. I'm solving this equation, and I get x equals a 4. But then again, as an ordered pair, and I should always write this as an ordered pair, that was 4 for x and a 0 for y. All right? And now I have to do the same thing for y. And I kind of ran out of space here. So the y-intercept is when I plug a 0 in for x. So here I go. Ready? I plug a 0 in here for x this time. And maybe you can take a little bit of a shortcut here. You probably don't have to show this step that I'm showing right now. You could probably go right to the minus 4y equals 12. And now I divide each side by the negative 4. So I get y equals a negative 3. And again, as an ordered pair, that's 0, negative 3. I had a 0 for x, and I got a negative 3 out for y. And so it's giving me these two ordered pairs. And the thing that's nice about this, the reason this is such an easy method, is because when the equation looks like this, where x and y are on the same side, and we'll talk about what that is in a second, some students will call this the cover-up method. They'll just essentially cover like this guy up with their hand and say, can I solve for y in my head? And hopefully you can look at that and go, yeah, y has to be a negative 3. All right, you could solve it in your head by dividing by the negative 4, or just thinking about negative 4 times what equals a positive 12. But we can solve that in our head and immediately write down this y-intercept. And then we could do the same thing. We could use the cover-up method and say, hey, let me cover up the y and solve for x. Because that's essentially what a 0 does. It eliminates that thing. And so solve this one in your head. 3x equals 12. Well, that means x has to be a 4, and there's my x-intercept, okay? And so that's what makes this really easy. We can just kind of solve this in our head. So cover up the x to find y, cover up the y to find x, and now you have your x and your y-intercept. And watch what happens when we plot this. This is enough information for us to graph this thing very accurately. So we've got 4, 0 for the x-intercept. We've got 0, negative 3 for the y-intercept. 2 points is enough to give me the pattern. Let's think about the pattern to get from one point to the next. It's up 3 over 4. So I could do that again, up 3 over 4, and there's my next point. Or taking it in the other direction, down 3, back 4, down 3, back 4. Continue that visual pattern of how the points are related, and now I have a very accurate line that I can graph. And notice it took almost no time at all if we're solving for x and y in our heads, okay? This format is known as standard form, okay? And there's a lot of information here about standard form. Really, for our purposes, the only thing that really matters or should matter to you is that it's x, y equals number, all right? X value, y value equals a number. The thing that's most important for you is just the order of this thing, okay? The fact that x and y are on the same side and it equals some number. All of this stuff down here is not really important, okay? This stuff can be summarized as, hey, no fractions, no negative for x, and no numbers that can divide into everything. Although some textbooks don't even bother with that third one, okay? So the big thing is no fractions, no negatives for x. But again, if something asks you for something in standard form, if you can just get it to the point where it's x value, y value equals a number, you're in good shape, and that's all that really matters, okay? The only time you'll be asked for technical standard form is on a standardized test, all right? And you don't have too many more of those in your lives left, so let's just focus on x, y equals number, okay? And if it's in that format, x, y equals number, that's when we can kind of use that cover-up method to find the intercepts. And that's the easiest way to graph this thing. For example, if I look at this guy, ready? Let's use the cover-up method. Let's say, hey, let me put a 0 in here for y, and now I'm going to solve for x. Can everybody solve that in your head? So think about it for a second. Say, okay, when I did this, x would equal a 2. And so now write it as an ordered pair. It's the ordered pair 2, 0. And now we do it again. Ready? Now let's cover up the x and solve for y. Let me scribble this guy out. And you can just cover up with your hand. If I have negative 4y equals 16, think about solving that in your head, or take it off to the side and do the work to solve it in your head, all right? You're still saving time by not actually writing the 0 down. If you just write this down and solve, divide each side by the -4, and it looks like you get y equals a -4. And again, write it as an ordered pair. That's the ordered pair 0, -4. So just make sure you write it as an ordered pair. And now from here, that's enough information for me to graph this thing, okay? So I'm going to plot those points. 2, 0 is right here. 0, -4 is down here. The pattern to get from one point to the next point is up 4 over 2. Up 4 over 2 would be here. Up 4 over 2 again would be here. And if I continued the pattern the other direction, it would be down 4 over 2. And the other thing that's neat about this one is actually there's points in the middle. Like if you were to describe the pattern up 4 over 2, think about a pattern that would be the same as up 4 over 2 or be equivalent to up 4 over 2. And hopefully you can see that it would be up 2 over 1. See these points that are in between that we could easily graph that fall in line with the pattern? Okay? And really, it's just a reduced form of that pattern. Instead of up 4 over 2, think of it like a fraction. It's up 2 over 1. All right? Now I can graph that line. And again, make sure you put those arrows on each end. The pattern continues forever. All right? If I look at the next one, again, we're going to do that cover-up method. And so for this one, I'm going to cover up the y to solve for x. So I plug a 0 in for y. There we go. I'm covering it up. And now this one might be a little bit more difficult to solve in your head if you're still scared of fractions, right? But we know that fraction bar is a division sign, right? Times -1/2 is the same thing as divided by -2. That's what a fraction bar means. That's a division sign. That's divided by -2. So think about it. How do I undo dividing by -2? And you can take it off to the side if you need to. Again, do not be afraid to take this off to the side and say, okay, I know that to undo dividing by -2, I have to multiply each side by -2. And now I know that these cancel, so I get x equals a -12. All right? It's okay to do that, all right, off to the side. You don't have to solve these in your head, all right? I'm just trying to encourage you to give it a shot, to give it a try, okay? But again, write it as an ordered pair. That's -12, 0. Okay? And now I got to do the cover up to find the y-intercept. So I'm going to cover up the x this time. Let me scribble that guy out for a second. Again, you just cover it up with your hand. This one you could probably solve in your head. 3y equals 6. That means the y value has to equal 2. And again, write it as an ordered pair. That's 0, 2. And so now I go to plot this thing, all right? And hopefully you're already looking at it going, oh, there's a little bit of an issue there, Mr. Jansen, all right? But let's see what happens. Ready? -12, 0. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12 is over here-ish. I don't know. That thing's way off the graph, right? Let's plot the other one, see what happens. 0, 2 is right here. So now if I'm looking at the pattern to get from one point to the next is like up 2 over 12, right? Based on where that x-intercept is. And again, that doesn't quite fit on my graph. Now my other point's going to be off the page. I can't even plot that at all right? But again, think about the last example. The last example was up 4 over 2, but it was also, that was the same as up 2 over 1. So if I were to think about the last example for a second, it was up 4 over 2. If you kind of think of it like a fraction, that's the same as up 2 over 1. So this one, same kind of thing. If the pattern is up 2 over 12, well, wouldn't that be the same as up 1 over 6? All right? And so we'd have that point in between. If you went up 1 over 6 here, put us right here, right? It would put us in between. It would put us at -6. So from -12, up 6 is +6. Okay, sorry, -6. And now this one, I could keep going, up 1 over 6. And so by kind of just thinking about that pattern, think of things that are equivalent to that pattern, we can still graph this thing, even though this guy is way off our graph and we should probably not bother graphing it, okay? And so this time I used the x and y-intercept to graph, but I don't even have the x-intercept on my graph. That's how powerful this can be, okay? So keep that in mind. We're finding those 2 points. The points identify the pattern, and then we can keep graphing from there. okay? But again, cover up, plug a 0 in for y to find x, plug a 0 in for x to find y. So for this one, you're planning a banquet and need to rent tables to seat 180 people. Tables come in two sizes. Small tables seat 4 people each, and large tables seat 6 people each. Write an equation that models the situation. So the first thing I should do is I'm going to write variables for each of these. So I'm going to say x equals the number of small tables. Okay? And then I'm also going to say that y equals the number of large tables. Okay? And so when I think about how many people I need to seat here in terms of an equation, each small table seats 4 people. So like if I had 8 small tables, that would be 32 people. All right. And most of us can kind of think of that and say, well, yeah, of course it's multiplication. But now when we're dealing with variables, we find that a little bit trickier. So I'm going to say 4 people per small table. So that's written as 4x. And when you hear that like per, all right, that's typically like a multiplication type of situation. Plus, we're also going to have 6 people per large table, so 6y, all right? So in other words, each large table seats 6 people. To figure out how many people the large tables fit, it's how many tables we have times 6, all right? But now here's the thing, that's telling us about how many guests we have. It's 4 people per small table plus 6 people per large table, and we need that to equal how many people? And the answer is 180. And you notice the way this is written, it's kind of showing this thing in standard form, all right? So keep that in mind. And so now it asks us to graph. Ready? So I'm going to graph this thing. So using my cover-up method, I'm not going to scribble it out this time because that would be annoying to me. So think about it in terms of the cover-up method. If I were to cover up the y, I would just have 4x equals 180. Right? And now you might not be able to solve that one in your head. That's okay. You might need to grab your calculator. You might even need to show the dividing each side by 4. And that's all right. Actually, maybe I should show that. Ready? Divide each side by 4. It's okay to show that work, and you get x equals a 45. Okay? But again, write it as an ordered pair. That's the ordered pair 45, 0. And now do the same thing for y. If I were to cover up the x, I would just have the 6y equals 180. And once again, that might not be one that you want to do in your head, so maybe you want to show the divided each side by 6. That's okay, all right? There's nothing wrong with that, and you get x equals a 30. But again, y equals a 30. Reading is hard. Y equals a 30. But again, write it as an ordered pair. That's the ordered pair 0, 30. Oh, and it looks like I already have this thing graphed over here for some reason. For this one, the thing that's trickiest about this, if I can select that guy, the thing that's trickiest about this guy is the fact that these numbers are so large, I might have to scale this thing differently. So instead of going by ones here, maybe I want to go by something like 5s. You know what I mean? So for my x's, maybe this is 5, 10, 15, 20, 25. And notice I'm labeling every other, only because my handwriting is probably too big to fit that here. Same thing with the x's. Maybe I go by 5s. Maybe this is 5, 10, 15, 20, 25, 30, 35. But now plot these points. So like here, that's the 30. This is the 45. And I'm assuming that's the line I already had here. Let me bring it back into play if I connect those with a line. Yeah, it sure is. Okay. And see, though, the thing here is, again, we had to rescale it. And I used this this line tool to make sure that the line was really accurate, because the next question here, list 4 possible combinations of tables. Well, just look at other ordered pairs that are on here. And I wouldn't want to pick like this one because I can't tell exactly what that is. But I would choose something like this guy because I can tell exactly where it is. This guy, I can tell exactly where it is. And depending on how you scaled this thing, you might have other ordered pairs that you can identify. Okay? And so if I make a list of 4 possible table combinations, the y-intercept is the first one I see. That was 0 small tables. with 30 large tables. See, that would be one option. I could just do all large tables. The next ordered pair I have looks like 15, 20. So that would be 15 small tables and 20 large tables. The next order pair I have is 30, comma 10. So again, that's 30 small tables. I guess I can abbreviate small as well. And what I say, 10 large tables. And then the last one is the x-intercept. That was 45 small tables and 0 large tables. And see, it's important to kind of look at that and identify other ordered pairs that aren't here. And there's a bunch of other combinations that we could use. And in fact, we could have seats that are empty, all right, but that's probably going to cost us more money in terms of the rental. So then the follow-up question here is, let's say, based on these values, if small tables rent for $9 each and large tables rent for $14 each, which combination above is the best deal? And so if you kind of like think about this for a second, so like that first one says 0 small tables, so none at $9, but 30 large tables, that's 30 tables at $14 each, so I have to do 30 times 14. So that first combination would cost me $420. Okay, that's if I did all large tables, right? If I did 15 small tables, that would be 15 times 9, which is $135, plus 20 large tables, that's 20 times 14. So that gives me a total of $415. The next one would be 30 small tables, so 30 times 9, plus 10 large tables, so 10 times 14. So that gives me a total of $410. If you notice, the price is going down. And so the last one, 45 small tables, just 45 times 9. So that's $405. And so what's interesting here is based on these prices, getting all small tables would be the best deal. So the question is, why would anybody rent large tables? Well, think about setting up tables. If you have large tables, there's more space in between for people to walk and mingle and that kind of stuff. So it really depends on what you're doing. So you might be willing to pay the extra money for the large tables so you don't have as much setup, that kind of stuff. Okay, so keep that kind of stuff in mind. You know, this is how some of these equations would be used. All right, but back to the basics of this thing. All we need to graph a line is 2 points. And those 2 points give us the pattern to plot more points. And the easiest 2 points to find are the x and the y-intercepts, okay? To find the x-intercept, you plug a 0 in for y. To find the y-intercept, you plug a 0 in for x.